I do believe you will find this part of the chapter test way easier.
Like you said that every single time before, but it's
No, I knew that first half of this chapter, that was hard. Okay? This part, the 5-7, in my opinion, is the hardest part because that was where we were working with the fraction exponents. Okay? And remember, the fraction exponents can translate to radicals. Okay? So if I have 16 to the 1/2 power, what does that mean?
Square root of 16.
It means the square root of 16. Now, on most of these, you literally, like that one, you could put it on your calculator. Okay, so if it comes out whole, you can do it. But guys, if you get a decimal value, you got to go back and do it by hand. Okay, so on your test, you can always try to put it in your calculator and see if it'll work. What is the square root of 16? 4. Okay. If I put 16 raised to the 1/2 power in my calculator, it's going to give me 4. Okay? The one thing I would caution you on here is your calculator now is set up in complex mode, which means it accepts imaginary numbers. I always have a difficult time on this because you know imaginary numbers now. So technically on 5-7, if I did this, you would say, oh, it can't be done. But I have got to accept that as an answer because you know how to do imaginary numbers now. So you could tell me, oh, you can't do it, okay, if it's in the 5-7 part. But I would say just go ahead and leave your calculator where it is and just give me the I answer, okay? All right, so let's do, if you look at your thing, you've got at the top of this, and you'll notice that it says page 9 on it, because what I did is I just broke your study guide in half, okay, and I did 3, 5, 6 on the other one. So an example there, if I have 4 to the 1/2 power, it's the square root of 4 or 2. If I have 8 to the 1/3 power, it's the third root of 8 or 2. So if I have W, and look at this one, to the -4/5 power. What does that negative on the exponent do?
Moves it to the bottom.
Takes it to the bottom. So if I wanted to, now this is where you can do it 2 different ways, okay? Some of you are doing it this way, and you go, in order to get rid of that root on the bottom, I have to have 5/5. So I multiply this by something like, 1/5. Because remember, if my base numbers are the same, I add my exponents. What I do to the bottom, I also do to the top, which gives me W to the 1/5 power over W to the 5/5 power, or just W. Okay, you can do it that way. Or you can translate it into roots. Now that's going to be your index. So it's the 5th root of W to the 4th power, which means I need one more W for the index and the power to cancel out. So I would multiply it by, now this is not a division line, that I should have done it that way. Okay, that's 2 different ways to do it, okay? So I'm going to multiply it by the 5th root of W. On the top, it's going to give me the 5th root of W. On the bottom, it's going to give me the 5th root of W to the 5th power, which is just W. This right here is the exact same thing as that. Okay, I'm going to change pens because I'm not sure to show up on the video. Okay, does that make sense? Okay. What if I have, and this is what I would say about this section. If you can't do it by roots, switch it and do it with exponents. If you can't do it with exponents, switch it and do it with roots. Okay, go back and forth between the 2 of them. If I have something like this, and this is at the bottom of your study guide, actually it's the middle of your study guide. And you go, what in the world? Well, That'd be like saying the square root of x times the fourth root of x to the third power times the fifth root of x. Normally, I can't do anything with that because they have to all have the same root to be able to multiply together. So what they've done is they've switched them to exponent form. Now, if the base number's the same, what do I do with their powers? If the base number's the same, then I'm multiplying. I add them. And I have to add them, I must do what? Find a common denominator or do it on your calculator. Okay? Put it in parentheses and you can add 1/2, 3/4, 1/5, and then convert it back to a fraction. Okay? If you want to do it by hand, the common denominator is going to be 20. Okay, so this one's going to be 10 over 20. This one's going to be 15 over 20. And this one's going to be 4 over 20. When I add all those together, I'm going to get x to the 29th over 20 power, correct? Is that not what you have?
3 over 40. I got 3 over 40.
3
I
over
got
what?
29 over 20.
You got 29 over 20. Okay, did you put parentheses
I
in
got
there?
3 over
Yeah.
40.
Yeah, I got 3 over 40.
I did half times 3 over 40.
Yeah.
I got
No,
the right answer.
not times, you're adding.
I got 29 over
You're
20.
adding, okay, the
gonna
base
say.
number's the same, you're
29 over
adding
20.
those exponents. Okay, it should give you 29 over 20 when you're done.
So I got
Okay, now here's the thing, 29 over 20 is the same thing as the 20th root of x to the 29th power. Remember how you can simplify that? 20 times what comes close to 29 without going over it?
1.
1. So I have an x on the outside. How many x's do I have left underneath there? 9. Okay, another way to do that is to come down here and you go, oh, that's the same thing as 1 and 9/20. So I have my x to the first power times my x to the 9/20 power. This and that match.
Oh.
Okay? That's probably an easier way to do it. Unless you don't understand that way. Don't understand that way. All I did was I took the 29 over 20 and made it into a mixed numeral. Okay, you remember how to make a mixed numeral out of an improper fraction? I divide 20 into 29. It goes one time with 9 left over. I place it over the 20. So I separate this into, because remember, those you just add together. If I have a base and a base. But what I've done here is I've pulled it out. But if you don't understand it, do it like this. And pull it out like you did at the beginning of the chapter. Okay? Alright, moving to the bottom of that first page. Let's say I have the square root of 13 times the cube root of 13. Can I do anything to that? Not the way they are. So when I look at something and I say, oh, I can't do anything, that's when I switch them to the exponent form. So this is, how do I write that with exponents?
13 and a half.
13 to the 1/2, because it's the square root of 13. How do I write this one?
1 over 3.
Right, 13 to the 1/3. Now I'll do just like I did with the x's. I find a common denominator. So the common denominator is 6, or I do it on my calculator. 1/2 plus 1/3, okay? So with a common denominator of 6, I have 3 over 6 times 2 over 6, which is going to give me 13 and 5/6. If the top number is not bigger than the bottom number, you just leave it like that, because there's nothing you can pull out.
The study guide messed up because it had 13 and 2/3 instead of 13 and 1/3
Oh, no, I
or something.
didn't see it. I didn't write it as a study guide. Okay, so then let's do this. So that's going to give me 4, which is then going to make this a 7. Now I can't leave it like that. If the other one was true, I could have left it like that. And I just didn't do the same problem the study guide had. I missed the 2. Okay, so I have 7/6. If I want to do it the way with the exponents, that's the same as 1 and 1/6, which is equal to 13 to the first power times 13 to the 1/6 power. Okay? If I don't want to leave it like that, I can go, this is the 6th root of 13 to the 7th power. 6 times what comes close to 7 without going over it? 1. So one of those 13s come out, and I'm left with 1 underneath it. That and that are the same thing. Okay? Yes, no, maybe? Sort of, kind of, y'all look a little vacant. Okay, that was section 5.7. Okay, what did I give you what to do after that section? All right, I'm gonna just pull an odd problem up here. All right, simplify that problem, or evaluate that problem, if you will. Converted that. Colin, you got it? Okay. Colin smartly picked up his calculator to see if he could do it on his calculator first. Okay? He got a decimal value, but then he thought, I wonder if that decimal value converts to a fraction, because that negative takes it to the bottom, so you know you're gonna have a fraction. So when he did it on his calculator and converted it back to the fraction, he got 1/9. Okay, and that's work smarter, not harder. Okay, always try with your calculator first.
That's it.
Go on. Did you do that?
I still know how to do it by hand pretty much.
Raised.
So I do the raise first?
You have to do the raised. Yeah, you have to do the raised.
I did it after.
Okay, and then negative 2 divided by 3.
Okay.
It's gonna give you that. If you go back to math, it's gonna give you that.
I don't really know how to do it by hand though.
Do I?
I don't know how to do it.
On your calculator?
Both.
Both, okay. If you go to do it on your calculator, you got 27, and then you're gonna raise it to the negative. Make sure you use the negative and not the minus, or you'll get an error statement. Okay, and it's gonna give me that. Go back to math, get fraction. It's gonna give me that. Okay, I'm gonna show you how to do it by hand.
Yeah,
Just in case you didn't know how to do it on your calculator or you forgot. Okay. The negative means I'm gonna go to the bottom, the exponent, the negative on the exponent. So I have 1/, this is the same thing as the cube root of 27 squared. Okay, that's one way to set it up. Now, you could, on your calculator, take the cube root of 27 squared, and you're gonna get 9. Okay? If you wanna do this in a different way, some of you this will make sense to, some of you it won't. If I write 27 as a base and a power, it's the same thing as 3 cubed is what 27 is, okay? 3 times 3 times 3 is 27 to the 2/3 power, okay? So I've got 3 times 2/3, which is gonna give me 1/3 squared, which is 1/9. Okay, there's all kinds of ways to do this. Okay. All right, then we moved on, okay, so that's that section, okay, you'll have review homework on that. We moved on to the next section, which was solving these things, okay? So on 5.8, we're solving these equations, and the thing that you need to remember on this is the opposite of a square root. To get rid of a square root, you're gonna square something. To get rid of something that's squared, you're gonna take the square root. So, and I do think that y'all had an easier time with this section than that section we just did. So if I have nice easy problem here. The square root of x is equal to 3. How do I get rid of that square root? Square both sides, okay? So when I square the left-hand side, what do I get?
I would agree. Right.
Okay, the right-hand side, I agree, I get 9. What do I get when I square the left-hand side?
X.
Just x, okay? Because when I take a square root and square it, it's like saying the square root of x times the square root of x, which is the square root of x squared, or just x. So that's my solution right here, but I always want to go back in and make sure it works, because sometimes these things don't work when you put them back in. So the square root of 9 is 3, okay? So you're good on that, right? Not a problem. Okay, what if I have something like this? This is the next problem you see on there. That's the cube root of r minus 1. Now these can be done with exponents too. If you want to convert them to the exponents and do it that way, you're welcome to. What is the opposite of taking the cube root of something? How do I cube it? Okay, it's not real complicated, so I'm going to continue it down here. So I'm going to cube this. What I do to one side, I have to do the other side. So what do I get when I cube that? R minus 1. Okay, if you will, it's like the index and the power cancel each other out. Okay, and I get rid of the root. What do I have on the right-hand side when I cube it? 27. And then I just have to solve. So I'm going to add the 1, so I have r is equal to 28. Well, I plug it back in up there, and I say 28 minus 1 is 27. The cube root of 27 is 3, so it does work. Okay? Makes sense? Okay. Y'all remember doing all this? It really hasn't been that long ago. This part hasn't been the never ending like the first half of the chapter was. This is the last problem on that page. What am I going to do?
Square.
I'm going to square both sides. When I square both sides, I get this. Then I'm just doing algebra to solve it. So if I subtract the g, that's going to give me a regular g there. If I subtract the 3, or add the 3 to get rid of it, I'm going to get a negative 1. So I'm going to say g is equal to negative 1. Okay, you see that? I didn't have the variable on the left-hand side. But if I put negative 1 up there, okay, does it work? No, because then I'm taking the square root of a negative 5, and I can't do that. I'm not allowed to use i's right here. Not yet, okay? Plus, it won't work with the i's because this is going to be the square root of negative 5. This would be the square root of, let's see, that's going to be a negative. Well, actually, it does look like it would work. Okay, so I guess they're going to let you do that. Okay, did I have empty set there? I do. I guess that's because we didn't get to the imaginary numbers yet. Because when you pull that out, that's going to be I on the square root of 5, which is going to be equal to I on the square root of 5. Okay, I think on the test what I did, and if not, you can ask me, can I use imaginary numbers on this?
Well,
Okay.
would it still work, like, even if you did use imaginary numbers? Because negative 5 is still equal, like, the square root of negative 5 is still equal to the square root of negative 5.
Yeah, I'm saying if you used imaginary numbers, yeah, then it would work. And if you go back and you show me that you plugged it back in and it works that way and you've used imaginary numbers, I'll give you credit for it.
Extra.
Okay, so technically when you plug it back in, you're going to get I on the square root of 5 equals I on the square root of 5, which is the exact same thing. Okay, because this was in a section before you hit imaginary numbers, that's why they're saying this is empty set. Okay.
But what if you plugged it in both sides and you left it like you just had at the top, where it's like,
You'd still have to pull out the I for me.
okay.
Yeah, still pull out the I. Okay, I'm going to give you one of these to do. Okay, now remember, if you've got a square root and a number, you can move the number to the other side to get rid of it. You know, to get rid of everything but the square root. So in other words, let me do one of these.